Hello and welcome back, and welcome to Module 1 of our Cloud Security Essentials course. In this module, we will talk about cloud computing and security fundamentals. Now, within this module, we are going to cover 8 different concepts, 8 different parts of this module are really our objectives. Cloud computing types and service models, cloud security challenges and concerns, cloud and security shared responsibility, evaluating cloud service providers, what the differences are between the big 3 cloud service providers, cloud security benefits, threats and attacks in cloud environments, cloud security design principles, and cloud security architecture. In this module, we're going to talk about the fundamental cloud principles and the terminology that is essential to talking to customers and cloud engineers. You as students will be introduced to key cloud security concepts, along with threats and attacks that are seen in different cloud and hybrid environments. And after completing this module, you should have a foundational cloud and cloud security principles understanding and understand the key design and key architecture that will be necessary for setting the groundwork and having a level of understanding for the remainder of this course. So as we start, let's think about it from a cloud computing and security fundamentals perspective of what you're going to be introduced to. And we're going to introduce you to the foundational cloud and cloud security principles and the key design and architecture understanding for protecting the cloud against threats and attacks. We're going to look at 3 very key areas of understanding that you should really focus on as you move through this course, and really make sure that you go back and watch this module until you really grasp these concepts, such as the key cloud principles and terminology, the cloud security concepts, and then design and architecture to protect the cloud. How do we bring that all in? Because as we follow on and we continue through all of the modules of this course, we're going to piece together different areas of this architecture and this design. So we're going to build kind of that foundation of what you need to know and how you need to focus on some of these principles, these terms for other modules going forward. Let's start off by defining what cloud computing is. What is cloud computing? We mentioned it would probably take for granted by speaking about it like normal, in our normal day-to-day of this is in the cloud, my files are all in the cloud, my applications are in the cloud. What really is cloud computing? And the best way to define it is NIST does a very good job of defining the cloud, and this has kind of become the de facto definition of cloud computing. And for those of you that don't know who NIST is, it is the National Institute for Standards and Technology. It is a United States government organization. For those of you that are also familiar with things like the International Standards Organization, ISO, NIST borrows and utilizes a lot of what ISO puts in terms of an international standpoint into a set of documents, into different documents within their own NIST.gov website that's free for you to access. So if you go to NIST.gov, you can find all of this information. If you use your favorite search engine and type in NIST definition of cloud computing, this will come up. NIST is a very good resource because ISO charges you to access their documentation. NIST does not. So you can get a lot of what ISO has within the NIST documentation. But back to the definition of cloud computing. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configured computing resources. And the foundation of that is generally networks, servers, storage, applications, and then other services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of 5 essential characteristics, 3 service models, and 4 deployment models. And we'll talk about a lot of those characteristics. We already talked about those 5 essential characteristics within the definition: networks, servers, storage, applications, and services. Those are those 5 essential characteristics, but we'll talk more about the service models and the deployment models. Just to break down this definition a little bit, when we talk about this and talk about cloud computing, we generally do break it down. You enabling ubiquitous, convenient, on-demand network access. Ubiquitous, there's no boundaries to it. It's convenient because we can go, like the definition says later on, minimal management effort and limited service provider interaction. We can go out in a lot of cases and we can purchase access to a cloud service. You can go out, you can sign up to Facebook, LinkedIn without any difficulty. All you have to do is provide a minimal bit of information, usually first and last name, email address, create a password, and you are now consuming cloud technologies. When we think about building an infrastructure, building, say, a web application of our own, we go on to one of the cloud computing providers, Azure, Microsoft Azure, Amazon Web Services, Google Cloud Platform, Alibaba, Oracle Cloud, whatever they are, IBM Cloud. We can go and we can consume that by just signing up as a consumer. We can go on there, we can create a free account with many of them to try before we buy. When we get to a point where we can no longer qualify for a free account, we give them a credit card, they bill our credit card monthly. That's really how cloud computing creates that on-demand network access and that convenience to all of us. So let's get a little bit deeper into the cloud computing types and those service models that we talked about within that definition. So the cloud computing types, and if we go back to that slide said there were 4, and there really are 4, but we're going to focus on 3 of them, and I'll mention the 4th verbally rather than putting it in the slide because it's really not talked about a whole lot, and you might not even think about it, and if you think about the 4, you might think about something else entirely. But the 3 main cloud computing types are private cloud, public cloud, and hybrid cloud. The 4th one is community cloud. Surprise, you probably thought it was multi-cloud, but it's not. Multi-cloud has not made its way into the definition of cloud computing types at this point. It's more of a de facto cloud computing type that we utilize when an organization is utilizing more than one cloud provider. But primarily, most organizations are running in one of these 3 models. Most organizations are probably in a hybrid model to speak of. Very few that are a pure private or pure public in a lot of cases. The community model is interesting, and we'll talk about that here in a moment. Very similar to, it's a subset really of the private model. So when we think about private, we have our company has its own data center, and all of our equipment is owned by our company, and everything is built based on our specifications. We are in our own building. We have our own data center, all owned solely by us as the company. It provides a lot of flexibility, obviously, in implementation because we own everything. So we just buy what we need. You must have that physical location, though. So there's a cost to real estate, obviously, as well as there's a high capital expense because you have to invest and purchase that equipment, depreciate that equipment. It goes into the balance sheet of your organization as a capital expense. The public cloud is hosted by the cloud provider. It provides a lot of geographic flexibility based on locations and regions and things of that manner. It also moves that capital expense to an operational expense. It is a monthly spend, much like your broadband cable bill or your cell phone bill, your electrical bill goes into an operational expense. So it provides a lot more accounting flexibility to our organization, as well as geographic flexibility and really size flexibility. There's a low cost to entry. It's usually 0, or, and like I said, you can get free for a certain amount of time and then build up to a cost model to your organization. The cost entry really is based on manpower and what you're able to do from a standpoint of building those, building out that infrastructure or migrating your existing private infrastructure into the public cloud environment. I'm going to step back for a second here and talk a little bit about community cloud before I get into hybrid cloud. Community cloud is a private cloud, but it is a private cloud owned by multiple organizations. Think about it in terms of maybe a consolidated school district, or maybe a local government has budgets coming from different areas like police, fire, county or township offices, library. They're all buying in, and there's a budget investing in that cloud, and then they're sharing those resources. There may be even a few small towns that go in to purchasing the infrastructure to build a particular application. Maybe it's, again, a library, a group of libraries that are using one library system to share the checkout of books and the inventory that they have in multiple locations. That's really that community cloud. It's organization-owned equipment in a shared location purchased by multiple organizations, a community of people. That's really what a community cloud is. Like I said, not as popular or really talked about as private, public, and hybrid, but that is the fourth of the 4 cloud computing types. So now let's move to hybrid cloud. Hybrid cloud is the combination of any 2 of the types. So it could be a combination of community and public, but in most cases, we talk about hybrid cloud and it's a combination of public and private. It provides the most flexible solution because it's utilizing the best of both. If we have a highly regulated environment, it's very good for that, because if we aren't ready to take that environment to public cloud, we can keep it in our private cloud and utilize both public and private and use the best of both worlds. It combines that capital and operational expense as well. So, where we have budget to invest in capital expenditures, we can certainly do that. And where we can take, where we want to move to an operational expense, we can do that as well. Good example of this is, you have an application that has been utilized for years and years and years. It is not the developer of that application. It was using proprietary technology, proprietary programming, and it's going to be quite an uplift and change to recreate that application for the public cloud. It's not, it's not what we call cloud ready in terms of an application. However, our website is built on .NET. We can very easily take our website to the public cloud. It gives us a lot of benefits from that standpoint of flexibility and elasticity, to handle the volume of information that might come during the holiday season when a lot of people are coming to purchase things on our website. All of that goes into, a prime use case for building our website on the public cloud, as well as other areas of email, SharePoint, Google Docs, Google Suite, using those, collaborative and productivity tools on the cloud also avoid our need to deploy them locally and give us a lot more flexibility in terms of licensing and things like that as well. So that's really a use case for hybrid cloud. The cloud service models, like we said in the definition, there are 3 types. When we talk about them, when we talk about infrastructure as a service and platform as a service, we're talking about when we're building applications and we're utilizing applications in the cloud. We're using Azure and AWS and GCP or Alibaba or Oracle, any of those public cloud providers. We're generally doing those as a infrastructure as a service or a platform as a service. Our software as a service is like Microsoft 365, Google Suite, LinkedIn, Facebook are all SaaS-based models. and they are provided fully web-based applications that are ready to go. We just need to purchase the license based on features and functionality that we want to have, generally purchased on a per user basis. As a customer, we generally only manage what users we put on there, what and how our data is handled. Again, I gave multiple examples on the slide, as well as mentioned a couple others. So that's software as a service. Let's jump back to infrastructure as a service. Infrastructure as a service is the closest to a private cloud. So we have the most responsibility as the customer on the infrastructure, except for actually providing the physical infrastructure. The cloud provider is going to provide you with all of that, the compute and storage and the software-defined networking environment that you need for your cloud environment. You then get that, you turn on and build virtual machines, you build your virtual network, and you have to then manage and maintain that, which includes patching your operating systems and things, just like you would in your own private data center. It's the most like that private cloud implementation. A lot of times when organizations are making a cloud transformation from a private cloud and moving an application to a public cloud, their easiest path is to an infrastructure as a service, and we call it a lift and shift in a lot of cases. Because we're just taking what is probably a virtual environment in VMware or OpenStack or something like that, and moving those images into a public cloud environment. And so then we start to figure out ways to refactor and redesign our applications and our databases and things to platform as a service. Platform as a service was really the influx of like app stores that we have on our iPhones and in Google, and was really initiated by platform as a service. Platform as a service is ideal for those app developers and for somebody that just wants to develop applications, doesn't want to worry about infrastructure and patching and things like that. They want to create apps. They want to create apps for the App Store. That's what platform as a service is for. The virtual machine, all of that, the networking and storage and all of that is built on a single platform that's maintained by the cloud provider. So it makes it very easy for those application developers just to build their applications, build their code, and push it onto a platform as a service. You're always going to be working on a platform that is patched, up to date, and has the most recent and stable operating system. So those become very key to the overall and usability and application development aspect of platform as a service. Many databases like Cosmos DB, PostgreSQL, SQL databases, relational and NoSQL databases are generally available in the cloud providers as a platform as a service, because anybody that's ever worked on a database knows how volatile they can be, especially when a patch update takes place and somebody runs a patch that breaks the entire database. This helps to avoid that from a database perspective.